In a previous video, I showed the design of a sine wave shape. I also promised a future video using that as a nice gripping surface. So here it is. For this video, I'll be using the Lattice 2 workbench extensively. If you don't already have Lattice 2, I highly recommend it. You can install it through the add-on manager. Start in the part workbench with the sine wave and all of the supporting sketches and discretized edges copy-pasted into the model. I'm going to create a gripping surface on a cylinder 50 mm in radius and 100 mm high. First things first, this sine wave is going to be a little bit too big for that. Fortunately, it was designed parametrically. Select the sketch inside one of the discretized edges that form the scaffolding for the sine wave. As you might recall, we have named constraints for wavelength and amplitude. With the sketch selected in the data pane, change the wavelength to 20 mm. Change the amplitude to 15 mm. Now to create the cylinder to hold the gripping surface. Create a cylinder radius 50 mm and a height of 100 mm. I don't want to do a regular pattern here. I want a pseudo-random sort of distribution of the sine waves over the surface of the cylinder. For now, hide the cylinder and switch to the Lattice 2 workbench. In order to place the sine, we first have to create a placement attached to it. Select the 2D offset for the sine wave and create an attached placement. Set the attachment mode to XY on plane. Really, inertial CS would be just fine as well, but this one's convenient. Now to create the Lattice 2 array. Bring the cylinder back. Get it centered well in the view and select the placement shooter. This is a tool that allows us to set arbitrary placements on an object and gather them into an array. Just click on the cylinder at various places where we want to put a sign. Rotate the cylinder around so we can cover it on all sides. So the cylinder is covered in placements now, all of which are gathered up into shot array. Now to place copies of the sine wave. In the model tree, select the offset 2D for the sine wave. Select the attached placement, and then select the shot array. Go to Lattice 2, Populate with Copies, Move Copies. This places a copy of the sine at each of the placements in the shot array. The signs are oriented in the same relationship to the placement as the original is to its attached placement. I think I'd like the signs to be a little bit more at an angle. Hide away the cylinder in the shot array and have a look at the sine wave again. Select the attached placement and in the data pane, adjust attachment.angle. Increase it to somewhere in the neighborhood of 25 degrees. Now bring back the cylinder and the moved offset 2D, and you can see that the signs have now rotated. Now the natural thing to do would be to go into the part workbench and extrude the moved offset 2D, but as you can see, if I attempt that, the extrude fails. Extrude wants to extrude everything along a normal line, but because the shot array is wrapped around a cylinder, there is no single normal line to each of the 2D offsets, and we get the failure. This is a problem with two solutions. If you've installed my grab bag tools introduced in a previous video, you can go back to the Lattice 2 workbench and use the extruder tool. Just select the moved offset 2D, then the extruder. It works very similarly to extrude, but it's designed to work with Lattice 2 arrays. It extrudes each individual copy of the object along its own normal line. Select the extruder in the model tree, and in the data pane set an offset of -2 and a length of 4. We want that additional offset because the signs are placed on the cylinder tangent to the surface. We need a negative offset deep enough that the furthest reaches of the sign are embedded within the cylinder. and a length large enough that even the most deeply embedded parts are sticking out of the cylinder at the desired distance. Otherwise, the sines will be stuck on in the middle and there will be gaps at the ends. Looking at it sideways, I can see that there's still a little bit of a gap at the very ends of the sine waves. So select the extruder again, change the offset to -3, and increase the length to 5 to compensate. Now we have the grips properly embedded into the cylinder. If for reasons incomprehensible to me you just don't want to install the grab bag, there is another way. Go into the part workbench, select the original sine wave, and extrude. Set the length to 3 and check the box for symmetric extrusion. That certainly gives us the shape that we'd like to attach to the cylinder, but we need to get it into the shot array. Select the moved offset 2D, and in the data pane under Lattice Population, select the object property and click on the box with 3 dots to the right. This brings up a dialog to select what object is to be relocated in the array. Click Clear and select the extrude that we just made and OK. Now instead of the offset 2D being placed, it's placing our extrusion. That looks about right. But I wanted the grips to follow the curvature of the cylinder. As you can see from the top view, even though they're embedded into the cylinder, the surfaces are flat rather than cylindrically curved. We can round those off to make them properly curved like the cylinder. Still in the part workbench, create a tube. Set the inner radius to cylinder.radius plus 2 mm, the desired height of the grip. Set the outer radius to inner radius plus 5 mm. It really only needs to be thick enough to completely cover the extrusions, but it's better to overdo than to underdo here. Set the height to cylinder.height. Select the moved offset 2D, which is actually the moved extrusions. Select the tube and cut. It takes a moment to think about that, and now the grips are nice and rounded so that they conform to the shape of the cylinder. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.